Hello students, in the last session we people have studied about the Faraday's laws of electromagnetic induction. In that, whenever the magnetic flux through a circuit changes, there is an induced EMF or current in that circuit, and this induced EMF exists as long as the change in magnetic flux continues. And second law in that, the induced EMF is directly proportional to the time rate of change of a magnetic flux linking with the coil or in a circuit. Based on that, we are written by the equation induced EMF E is equal to minus d pi b divided by dt. The negative sign that indicates once an EMF is induced in the coil, which can oppose us the further change in magnetic flux through a circuit. Therefore, that is studied by the one more law. That law is called as an Lenz's law. Therefore, while studying the Lenz's law, we are given by the two important consideration that is considered as the physical significance of Lenz's law. The first one, law of conservation of energy, as well as the second one is known as the Lenz's law that can give the polarity of the induced EMF. In this session, we will start with the concept of expression for induced EMF based on both the laws, which means based on Faraday's laws of electromagnetic induction as well as the Lenz's law. In that, the first equation, EMF E is equal to minus d pi divided by dt. E is equal to minus, in the next step we are done by d pi is that refers to the change in magnetic flux. Therefore, that is expressed by pi 2 minus of phi 1 divided by t, and for n number of turns of the same coil. See here, the first equation what we have done, that is based on both the laws. E is equal to minus d pi by dt. In the next step, d pi is extended as pi 2 minus of pi 1, is it clear now, divided by t. And for n number of turns of the coil, if the coil consisting of n number of turns, the same equation is written as, nodi illi bardanta term hege barutide kelidre, E is equal to minus d pi by dt is taken as E is equal to minus n times of d pi divided by dt. In the next step, E is equal to minus n pi 2 minus pi 1 divided by t. Is it clear? Next, expression for induced current. Now, for that, I is equal to minus d pi divided by dt times of R. In general electric current, I is equal to V by R, where V is the voltage according to the Ohm's law, where V is the voltage, I is the current, R is the resistance. In terms of induced EMF or induced voltage, that is expressed by E. Illi voltage ಅನ್ನುವಂತ ಟರ್ಮ್ ಅನ್ನು ಯಾವುದು ರಿಪ್ಲೇಸ್ ಮಾಡ್ತದೆ ಕೇಳಿದ್ರೆ ಟರ್ಮ್ E ರಿಪ್ಲೇಸ್ ಮಾಡ್ತದೆ. ಇದೇ ಇಕ್ವೇಷನ್ ಅನ್ನು ಹೇಗೆ ಬರೀತೇವೆ ಕೇಳಿದ್ರೆ I is equal to E divided by R. Electric current, or sorry, induced current, not electric current, induced current, I is equal to E divided by R, where E is equal to, what is the term here, minus d pi by dt times of R. Is it clear? Therefore, the next step, expression for the charge is, what about electric current? I is equal to the time rate of flow of electric charge is called as an electric current. Therefore, I is equal to, we are done by, see here, what is the equation? I is equal to dq divided by dt is equal to minus d pi divided by R times of dt. Hope you clear that? These are the expressions that is used in the purpose of competitive or in 3 mark or in 1 mark numerical. In that, the term dt gets cancels. Therefore, dq is equal to minus d pi divided by R. Yes, what about the conclusion? See here, the induced current and expression for charge that depends upon the factor is known as a resistance. Therefore, the induced EMF, if we consider which is consisting of n number of turns, that does not depend on any resistance. Therefore, the note they are given, induced EMF does not depend on resistance of the circuit, whereas the induced current and induced charge depend on resistance. According to the equation they are given by the note. Is it clear? ನೋಡಿ ಇಲ್ಲಿ ಟರ್ಮ್ ಏನು ಬರೆದಿದ್ದೇವೆ ಅದಕ್ಕೆ ಬೇಕಾಗಿ ಇಲ್ಲಿ E ಅನ್ನುವಂತ ಟರ್ಮ್ ಬರೆದಿದ್ದೇವೆ, equation ಬರೆದಿದ್ದೇವೆ. What about E is equal to minus of phi 2 minus pi 1 divided by D is the near resistance over there. ನೋಡಿ ಇವೆರಡು ಅಥವಾ 4 equations ಅಲ್ಲಿ ಎಲ್ಲಿಯಾದರೂ resistance term ಅನ್ನು ಬರೆದಿದ್ದೇವೆ. That is the reason why induced EMF does not depend upon the resistance. But if you have taken the induced current or induced charge, it depends upon the factor is known as resistance. Then, methods of producing the induced EMF. The next concept we have taken, methods of producing the induced EMF. In that, the first method, by changing the magnetic field B, that you already studied in Faraday's laws of electromagnetic induction. When the north pole of the magnet, which is moved towards the coil, or which is moving away from the coil, the change in magnetic field takes place. That leads to the the change in magnetic flux across the coil. That is the reason why there is an induced EMF or a current in the given circuit. The same time they are given by changing the magnetic field B means here magnetic flux phi can be changed by changing the magnetic field B, and hence EMF can be induced in the circuit as done in Faraday's experiment. The second one, the methods of producing the induced EMF, the second process by changing the area of the coil E. By changing the area of the coil E available in the magnetic field. For that, we are taken by the uniform magnetic field. See here, this is considered as an uniform magnetic field. The uniform magnetic field in which we are taken by the area of cross section of the loop, that is considered as a PQRS. Is it clear? In that we are taken by the area of cross section of the loop is called as an PQRS. See here, the loop that are moved into the magnetic field regions. Note diagram and note first here. The term they are given. Before that they are given by the term. What is the meaning of by changing the area of the coil A available in magnetic field means the magnetic flux phi can be changed by changing the area of the loop A. See the sentence, magnetic flux phi can be changed by changing the area of the loop A, which is acted upon by the magnetic field B, and hence EMF can be induced in the circuit. For that we are taken by the uniform magnetic field region. In that we are taken by the rectangular loop that is known as a PQRS with the area of cross section is known as A. When that loop that move perpendicular to the directions of the magnetic field with the velocity is called as V, which means the length of the PQRS loop, the length is perpendicular to the direction of the magnetic field B, and that loop which is moving with the velocity is called as a V in a direction perpendicular to the magnetic field, that is expressed by B vector. Therefore there is a change in area that is expressed by dA. Now we are done by the term, here it is L from the point S to R dash, S to S dash or R dash to S dash. In general PQRS be the loop, while it is moving in an uniform magnetic field, that is expressed by P dash, Q dash, R dash as well as the S dash. In that we are written by when the loop that covers the distance traveled by the loop in a uniform magnetic field is expressed by V times of dt. Since velocity is equal to distance traveled by time, velocity is equal to distance traveled by time, therefore distance traveled is equal to velocity into that time, therefore that is expressed by V times of dt. Hope you clear that. ಮಕ್ಕಳು ಇದು ಗೊತ್ತು ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? ಇನಿಷಿಯಲ್ ನಾವು ಏನು ಮಾಡಿದ್ವಿ ಕೇಳಿದ್ರೆ PQRS ಅನ್ನುವಂಥ ಲೂಪ್ ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿ which is having the area of cross section A. When the loop that are moved in the magnetic field perpendicular to the direction of the magnetic field, the length of the loop is perpendicular to the magnetic field. Therefore, the distance moved by the loop in a uniform magnetic field is expressed by, with the velocity term, we are expressed by V times of dt. Therefore, the loop PQRS is slided into uniform. The loop PQRS is slided into uniform and perpendicular to magnetic field. The change, or which means increase in the area of the coil, that is the reason why we are done by dA. Under the influence of the field is dA in a time dt. Therefore, this causes an increase in magnetic flux d pi across the loop. Is it clear? That causes the increase in magnetic flux across the loop since the loop is moving in an uniform magnetic field region. Therefore, d pi is equal to B times of dA according to the definition of magnetic flux. Number of magnetic lines of force passes normally through the surface. Therefore, what about that term is expressed by magnetic flux. Therefore, change in magnetic flux d pi is equal to B is the magnetic field, dA is the change in area of cross section of the loop. Therefore, that is equal to, what about dA is equal to area of the loop is equal to V times of L times of V times of dt. Is it clear? The area of the cross section, length into the breadth, length is considered as an L. See here, area is equal to length into breadth, length is expressed by L, the breadth is expressed by, the distance is from S to R is considered as S dash to R dash. Therefore, what about the distance moved by an object, that is considered as V into dt, that itself is taken as a breadth. ಮಕ್ಕಳು ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? ನೋಡಿ ನಾವು ಏರಿಯಾ ಅನ್ನುವಂಥ ಟರ್ಮ್ ಅನ್ನು ಬರೆಯುವಾಗ ಹೇಗೆ ಬರೀತೇವೆ ಕೇಳಿದ್ರೆ ಏರಿಯಾ ಇಸ್ ಈಕ್ವಲ್ ಟು ಲೆಂತ್ ಇಂಟು ದ ಬ್ರೆಡ್ತ್, ಲೆಂತ್ ಆಸ್ ಯೂಶುವಲ್ ಎಲ್ ಅಂತಾನೆ ಬರೆದಿದ್ದೇವೆ, ಬಟ್ ದ ಬ್ರೆಡ್ತ್ is expressed as the distance covered by an object. Therefore, that is expressed by V times of dt. Therefore, that is expressed by length is L and area of cross section A is equal to length is L, V times of dt, where V is the velocity. Therefore, E is equal to minus d pi by dt. Therefore, what about the value of d pi is equal to BLV dt. The term dt gets cancelled out. Therefore, induced EMF E is equal to minus BLV. Therefore, the induced EMF is due to motion of the loop, which means movement of the loop, that is known to be PQRS. That is the reason why this is considered as motional EMF. Arrive the expression for questions ಹೇಗೆ ಕೇಳ್ತಾರೆ ಕೇಳಿದ್ರೆ 3 ಮಾರ್ಕ್ ನ ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್. ಬೋರ್ಡ್ ಅಲ್ಲಿ ಇದು ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ ಆಗಿರ್ತದೆ. ಕ್ವಶನ್ಸ್ ಹೇಗೆ ಕೇಳ್ತಾರೆ ಕೇಳಿದ್ರೆ arrive the expression for motional EMF ಅಂತ ಕೇಳ್ತಾರೆ. Is it clear? Arrive the expression for motional EMF. Therefore, what is the expression? E is equal to minus BLV. First you have to write the explanation for this. After the diagram, here the term they are given along with the equations. Is it clear? ಇಲ್ಲಿ ಒಂದು ಟರ್ಮ್ ಅನ್ನು ಬರಿಬೇಕು. ಚೇಂಜ್ ಇನ್ ಏರಿಯಾ or dA is equal to L times of V times of dt, where A is equal to dA is equal to, next E is equal to minus d pi by dt, that is equal to E is equal to minus of BLV. Therefore, the induced EMF is due to the motion of the loop, and so it is called motional EMF. Along with this, see here, if the loop is pulled out of the magnetic field, then E is equal to, if the loop is considered that are moving away from the loop or away from the magnetic field region. ನೋಡಿ ಇದೇ ಲೂಪ್ ಅನ್ನು ಏನು ಇಂಟು ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ರೀಜನ್ ಗೆ ಕನ್ಸಿಡರ್ ಮಾಡಿದಿರಿ, ಇದೇ ಲೂಪ್ ಅನ್ನು ಏನು ಮಾಡ್ತೀರಿ ಕೇಳಿದ್ರೆ ಇಲ್ಲಿಂದ ಹೊರಗಡೆ ತರ್ತೀರಿ ಅಂತ ಹೇಳಿದ್ರೆ, ವಾಟ್ ಅಬೌಟ್ ದ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ ದಟ್ ವಿಲ್ ಬಿ ಜಸ್ಟ್ ಅಪೋಸಿಟ್ ಟು ದ ಫಸ್ಟ್ ಒನ್. E is equal to minus BLV, that is considered as E is equal to plus BLV is the equation. Is it clear? Then the direction of induced current is anti-clockwise in the loop, that is P dash, S dash, R dash, Q dash, P dash by Fleming's right hand rule or the Lenz rule. The Lenz rule that can give the polarity of the induced EMF, that you already studied. Therefore, see the direction they are given. ನೋಡಿ ಡೈರೆಕ್ಷನ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಆಂಟಿ ಕ್ಲಾಕ್ವೈಸ್ ನ ಡೈರೆಕ್ಷನ್ಸ್ ಅನ್ನು ಇಂಡಿಕೇಶನ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ನೋಡಿ ಯಾರು ಇಂಡಿಕೇಶನ್ ಬರ್ತದೆ ಇಲ್ಲಿದೆ ನೋಡಿ, ಸರಿಯಾ? ದಟ್ ಮೀನಿಂಗ್ ಡೆಫಿನೇಷನ್ ಮೀನಿಂಗ್ ಇಲ್ಲಿ ಡಯಾಗ್ರಾಮ್ ಅನ್ನು ಕೊಟ್ಟಿರುವಂತದ್ದು. The according to the Lenz law is next. According to the Lenz law, the direction of the induced current is such that it opposes the cause of change in magnetic flux. Then here the cause of change in magnetic flux is due to motion of the loop and increase in area in the uniform magnetic field. The cause of change in magnetic flux, the magnetic flux is varies is because of the area of cross section of the loop or the movement of the loop as well as the area of cross section of the loop. Along with this, therefore, this motion of the loop is to be opposed, so the current is setting itself such that Fleming's left hand rule, the conductor arm PS experiences a force to the right, whereas the loop is trying to move to the left. Is it clear? Now, against this force, mechanical work is done which is converted into an electrical energy. The work is done in terms of when the loop is considered as PQRS, that is moving in a uniform magnetic field. Therefore, there is a mechanical work that converted into an electrical energy. Mechanical energy is converted into an electrical energy. In that, the note they are given, if the loop is completely inside the boundary of magnetic field, then there will not be any change in magnetic flux, and so that there will not be an induced current in the loop. These are the points they are given. No need to write in the exam. Just ನಿಮಗೆ ಇದು ಕಾಂಪಿಟೇಟಿವ್ ಯೂಸ್ ಆಗಬಹುದು ಈ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನುವಂಥದ್ದು, ಅಥವಾ ಕಾನ್ಸೆಪ್ಟ್ ಆಗಿ ನಿಮಗೆ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ ಯೂಸ್ ಆಗಬಹುದು. ಬಟ್ ಇಲ್ಲಿಂದ ಕ್ವಶನ್ಸ್ ಏನು ಬರೋದಿಲ್ಲ, ಜಸ್ಟ್ ಗೊತ್ತಿರಲಿ ನಿಮಗೆ. ನೀವು ಪ್ರೂವ್ ಮಾಡಬೇಕಾಗಿರುವಂಥದ್ದು ಅಪ್ ಟು ದ ಟರ್ಮ್ E is equal to minus BLV for the 3 mark question for the board. These are the knowledge wise questions or the knowledge wise topic. Next, Fleming right hand rule they are given. See here, the forefinger that indicates the directions of the field, thumb that points the direction of the force, the middle finger that indicates the electric current. Therefore, what about the statement? If the central finger, forefinger and thumb of the right hand are stretched mutually perpendicular to each other, and the forefinger points the magnetic field, thumb points the direction of the motion that consists of force, then the central finger points the direction of induced current in the conductors. The next one, methods of producing the magnetic field or the methods of producing the magnetic flux in terms of an induced EMF. Now the last one, by changing the orientation of the coil in magnetic field, by changing the orientation of the coil in magnetic field. Very important, one more 3 or 5 mark very important question. See here, magnetic flux phi can be changed by changing the relative orientation. Magnetic flux phi can be changed by changing the relative orientation of the loop that is known to be theta with the magnetic field B, and hence EMF can be induced in the circuit. For that they are given the diagram. See here. What about this line that they are indicating magnetic field that is expressed by B vector? In that we are taken by the loop. That loop is considered as a PQRS. When the loop rotates in an uniform magnetic field with an angular velocity is known as an omega. Initially the loop is attached that theta is equal to 0 degree as the loop rotates. Is it clear? In terms of a mechanical work with an angular velocity is called as an omega. The term they are given here such that it makes an angle with respect to the unit direction, that is considered as a theta. Therefore pi is equal to NBA cos theta is the term. Magnetic flux through the loop according to the moving charges and magnetism. We have studied about the definition where n is the number of turns, B is the magnetic field, A be the area of cross section of the coil, and theta be the orientation produced by the loop in a uniform magnetic field. Therefore at a time t with the angular velocity omega, theta is equal to omega t, which means if we consider the loop that is considered as a PQRS is placed in a uniform magnetic field. Initially the loop is considered as to be attached, therefore theta is equal to 0 degree. Is it clear? As it rotates with an angular velocity is called as omega. The angular displacement produced by the loop in a uniform magnetic field is expressed by theta is equal to omega times of t. Here at t is equal to 0 second, the loop is assumed to be perpendicular to the magnetic field. Therefore theta is equal to 0 degree. The condition they are given. Therefore phi is equal to, nodi alli theta is equal to 0 degree now term anna barililla. Therefore phi is equal to n times of B A. In place of theta we are done by omega t, therefore that is expressed by cos omega t. In the next step, differentiating with respect to t this equations ಅನ್ನು differentiate ಮಾಡಿದ್ರೆ ಏನಾಯ್ತು ಮಕ್ಕಳು ನೋಡಿ, ಇದೊಂದು ಟರ್ಮ್ ಏನಿದೆ phi is equal to n times of BA cos theta. This is the concept that are concept that are included in the chapter of moving charges and magnetism. Magnetic flux phi is equal to B times of A is the definition, along with the orientation that is expressed by cos theta. Sariya, where n is the number of turns. In that theta is equal to omega t, the same equation is considered as phi is equal to n times of BA. Theta is equal to omega t, that is expressed by cos omega t. Now differentiating this equation where n is the number of turns, that remains constant. B is the uniform magnetic field, that remains constant. Area of cross section of the loop is also considered as a constant. Therefore which one be the variable? Cos omega t is the variable, since here we are produced by the change in magnetic flux by changing the orientation of the coil. That is the reason why cos omega t is the variable. Therefore E is equal to d pi by dt is equal to minus NBA omega sin omega t. This omega sin omega t is because of d by dt of cos omega t. Yes, what about d by dt of cos omega t? Minus of sin omega t times of omega. That minus is taken as an outside. Nodi, while differentiating this equation, already agide nimage differentiation nodi, while differentiating this term, the differentiation of d by dt of NBA term ಅನ್ನು ನಿಮಗೆ ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗುದಿಲ್ಲ, ಸಿನ್ಸ್ ಇಟ್ ಇಸ್ ಅನ್ ಕಾನ್ಸ್ಟೆಂಟ್. ಸರಿ ಅಲ್ವಾ? ಹಾಗಾದ್ರೆ ಏನಾಗ್ತದೆ ಕೇಳಿದ್ರೆ NBA ಅನ್ನ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿ ಇಟ್ಕೊಂಡ್ರೆ d by dt of cos omega t is the term. Therefore d by dt of cos omega t will be minus of sin omega t into omega. Therefore that minus that are taken over here. See here, minus ಅನ್ನು ಇಲ್ಲಿ ಬರೆದಿದ್ದೇನೆ. ಆದ್ರೆ ಏನಾಯ್ತು, the NBA times of omega sin omega t. Therefore E is equal to minus d pi by dt. Therefore E is equal to, what about d pi by dt is equal to minus NAB omega sin omega t, that I substituted here. Minus of minus will be plus. Therefore NB omega sin omega t, NB omega sin omega t. While considering this equation we are getting as E is equal to E naught sin omega t. In that see here, NBA omega, that refers to E naught, where E naught is called as an NB omega is the maximum value of the EMF, where E naught is equal to NBA omega, that indicates the maximum value of the EMF. ನೋಡಿ ಮಕ್ಕಳೇ, ಇಲ್ಲಿ ಒಂದು ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಸ್ಟೆಪ್ ಇದೆ, ಜಸ್ಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿದ್ರೆ ಆಯ್ತು. ನಿಮ್ಗೆ ಏನು ಸಿಗ್ತದೆ ಕೇಳಿದ್ರೆ ಟರ್ಮ್ ಮೀನಿಂಗ್ ಕೂಡ ಸಿಗ್ತದೆ. E is equal to d pi by dt ಗೆ what is the value of d pi is equal to E is equal to minus d pi by dt. ಇಲ್ಲೇ ಟರ್ಮ್ ಕೊಟ್ಟಿದ್ದಾರೆ. Therefore minus of minus will be plus, that will be expressed as this like this. ಸರಿಯಾ? ಬರಿಬೋದಲ್ವ? ಏನು ಡೌಟ್ ಇಲ್ಲ. Therefore V naught is equal to NBA omega is the maximum value of the EMF, hence the proof. Is it clear? ಇಷ್ಟೇ ಬರೆದ್ರೆ 5 ಮಾರ್ಕ್ಸ್ ಸಿಗ್ತದೆ. Along with the diagram, very important diagram. 2020 the same question will ask for the board exam. March 2020 ಇದೇ ಕ್ವಶನ್ಸ್ ಅನ್ನು ಕೇಳಿದ್ದಾರೆ. Error the expression for magnetic or the induced EMF in the orientation of the coil, or the questions ಹೇಗೂ ಸಹ ಕೇಳ್ಬೋದು. ನಿಮಗೆ ಕೊಡ್ತೇನೆ ಅಸೈನ್ಮೆಂಟ್ ಅಲ್ಲಿ ಹೇಗೆ ಇದನ್ನ ಕ್ವಶನ್ ಕೊಡ್ತಾರಂತ. ಬಟ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ 3 or 5 ಮಾರ್ಕ್ ಕ್ವಶನ್ಸ್ ಬರಿಬೋದಲ್ವಾ? ಎಸ್. See here, the EMF changes continuously in the magnitude and periodically in direction with respect to time, giving rise to an alternating EMF, which means an EMF is changes with respect to the time. Therefore, when an EMF is changes with respect to the time, that is considered as alternating EMF. ಇದನ್ನು ನಾವು ಹೇಗೆ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೇವೆ ಕೇಳಿದರೆ, EMF or a charge or a voltage that is continuously change with the time is considered as alternating voltage ಅಂತ ಬರೀತೇವೆ ಅಲ್ವಾ? Therefore, the same term voltage ನ ಬದಲಿಗೆ ಯೂಸ್ ಮಾಡುವಂಥ ಟರ್ಮ್ ಏನು ಕೇಳಿದರೆ EMF. that is the reason why that is considered as alternating EMF. See there, alternating ಕೊಡ್ತಾರೆ ನೋಡಿ. the y axis in which we are expressed by the EMF, the x axis in which we are expressed by the orientation, theta is equal to omega t. Therefore, here they are given the term the y axis in which we are expressed by the time. Therefore, what about this graph that can give alternating EMF? Therefore, the EMF changes continuously in magnitude and periodically in direction with respect to the time. What it gives? It gives alternating EMF. Therefore, see the curve now. ನೋಡಿ ಮಕ್ಕಳು, ಅರ್ಥ ಆಗ್ತದೆ ನಿಮಗೆ ಟರ್ಮ್. cos pi, the value is 0. Pi by 2, the value is maximum. 3 by 2, the value is maximum in the reverse direction. Again, the value is minimum, 2 pi. Therefore, this curve is known as an alternating EMF. ಅಲ್ವಾ? ಮುಂದೆ ನಾವು ಇದನ್ನು ಚಾಪ್ಟರ್ನ ಸ್ಟಡಿ ಮಾಡ್ತೇವೆ. ದಟ್ ಚಾಪ್ಟರ್ ಇಸ್ ನೋನ್ ಎಸ್ ಆಲ್ಟರ್ನೇಟಿಂಗ್ ಕರೆಂಟ್. ಎ ಕರೆಂಟ್ ಚೇಂಜಸ್ ಡೈರೆಕ್ಷನ್ಸ್ ಪೀರಿಯಾಡಿಕಲಿ ವಿತ್ ಟೈಮ್ ಅಂತ. ಹಿಯರ್ EMF is changes ಡೈರೆಕ್ಷನ್. Is it clear? EMF is changes directions periodically with the time when it is maximum. It is maximum at t by 4 for the time period. For the time period of pi by 2 is minimum for the value of pi. Then maximum is in the reverse direction, minimum, maximum, minimum, maximum, minimum. Therefore, each time the EMF is changes with respect to the time. Therefore, that is considered as alternating EMF. Is it clear? Yes. See here, this curve that indicates maximum value of EMF, that is expressed by NAB omega, where N is the number of turns, A is the area of cross section, B is the magnetic field, and omega B is the angular frequency. See here, if the initial position of the coil is taken as 0 degree, see this point, that is normal to the coil is at 90 degree with the magnetic field, then theta becomes theta plus pi by 2, or theta is also written by omega t plus pi by 2. By that time, the value of the EMF, the E naught value will be maximum. Then E is equal to E naught cos omega t. As now, the one more graph they are given. See the graph now. E naught 0 degree, the EMF will be maximum. E graph ಅನ್ನು observe ಮಾಡಿ. For the angle of 0 degree, E naught will be maximum from this point. E naught will be minimum. Therefore, t by 4 or pi by 2 itself, the E naught will be maximum from this point. ನೋಡಿ, 0 ದಲ್ಲೇ ಕರ್ವ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇಂದ ಸ್ಟಾರ್ಟ್ ಆಗ್ತದೆ. Therefore, what it indicates? So, alternating EMF and consequently alternating current can be expressed in sine or in a cos function. Therefore, this method of inducing the EMF is based on the principles of generators. Is it clear? Nodi, for the value of theta is equal to 0 degree itself, it has the maximum value of the EMF. For the value of 0 degree itself, the value will be 0 EMF. But it is maximum when the value of pi by 2. Is it clear? ಏನಾದರೂ ಡೌಟ್ ಇದ್ರೆ ಕೇಳಬಹುದು. Yes, the continuation, the next concept is known as eddy currents, or that current is also called as Foucault currents. See here, listen here. If we consider the metallic plate, before introducing the concept, I will give the explanation for that. If we consider the metallic plate is placed between the two powerful electromagnets that is known to be N and S. When the electromagnet is switched off, the metallic plate is set into oscillations. ಒಂದು ಮೆಟಾಲಿಕ್ ಪ್ಲೇಟ್ ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡು ಏನು ಮಾಡ್ತಾನೆ ಕೇಳಿದ್ರೆ, ಆ ಪ್ಲೇಟ್ನ ಆಚೆಗೆ 2 ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟ್ಸ್ ಅನ್ನು ಇಡ್ತೇನೆ. ಸರಿಯಾ? ಆ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟ್ಸ್ ಆಗಿದೆ ಕೇಳಿದ್ರೆ, ಮ್ಯಾಗ್ನೆಟ್ಸ್ ಆರ್ ಸ್ವಿಚ್ಡ್ ಆಫ್. ಎಲೆಕ್ಟ್ರೋ which means the material which is having the electric field, therefore that electric field is off, or electric field is equal to 0 when the metal plate is set into oscillation. ಈ ಮೆಟಲ್ ಪ್ಲೇಟ್ಗೆ ಏನು ಮಾಡ್ತಾನೆ ಕೇಳಿದ್ರೆ, ಆಸಿಲೇಷನ್ ಅನ್ನು ಸೆಟ್ ಮಾಡ್ತೀನಿ. ಇದನ್ನು ನಾನು ಆಸಿಲೇಷನ್ ಕೊಡ್ತೇನೆ. It will oscillate for a long time. ನಾನು ಆಸಿಲೇಷನ್ ಕೊಟ್ಬಿಡ್ತೇನೆ, ಏನಾಗ್ತದೆ ಕೇಳಿದ್ರೆ, ಆಸಿಲೇಷನ್ ಆಗ್ತಾನೆ ಇರ್ತದೆ. ಒಂದು ಲಾಂಗ್ ಟೈಮ್ನ ತನಕ ಆಸಿಲೇಷನ್ ಆಗ್ತಾನೆ ಇರ್ತದೆ. ಸರಿಯಾ? In the next case, when the electromagnet is switched on, which means electric field is not equal to 0. Is it clear? The metallic plate is set into oscillations. The metallic plate is set into oscillation. The plate which comes to rest very quickly, since because of either side which is having the magnet, strong electromagnet, that is N and S, in which the coil is rotated, means the plate is rotated, means ಎರಡು ಕಾಯಿಲ್ನ ನಡುವೆ ಒಂದು ಮೆಟಲ್ ಅನ್ನು ಇಟ್ಟು ನಾನು ಆಸಿಲೇಷನ್ ಅನ್ನು ಸೆಟ್ ಮಾಡ್ತಾ ಇದ್ದೇನೆ ಅಂತ ಹೇಳಿದ್ರೆ, there is a change in magnetic field across this coil. Therefore, as there is the change in magnetic field across this coil, that generates the magnetic change in magnetic flux across the coil, that generates an induced EMF. Is it clear? Once an induced EMF is induced in the coil or this loop or the plate, metallic plate, it can oppose us the further growth in change in magnetic flux link in the circuit. That is the reason why it comes to rest, which means that the induced current which opposes the movement of the metallic plate. ಅರ್ಥ ಆಗ್ತದೆ ಮಕ್ಕಳೇ? ಫಸ್ಟ್ ಕೇಸಲ್ಲಿ ಏನು ಮಾಡಿದೆ ಕೇಳಿದರೆ, electromagnet is switched off. The electromagnet is switched off and it is set into oscillation. It will oscillate for a long time. In the second case, electromagnet is switched on. Electric field is not equal to 0. There is a presence of both electric field as well as the magnetic field. Since it is an electromagnet, when the metal plate is set into oscillation, the plate which comes to rest very quickly, since there is an induced EMF in the coil, and that induced EMF which can oppose us the further growth in change in magnetic flux, or which can oppose us the movement of the metallic plate. Is it clear? Therefore, this kind of opposition offered by the induced current to the metallic plate, this kind of opposition offered by the induced current to the metallic plate is called as an electromagnetic damping. But by that process we are inducing the current on that material. ಈ ಪ್ರೊಸೆಸಲ್ಲಿ ನಾವು ಏನು ಮಾಡಿದ್ದೇವೆ ಕೇಳಿದರೆ, ಒಂದು ಮೆಟೀರಿಯಲ್ನ ಮೇಲೆ ಅಥವಾ ಮೆಟಾಲಿಕ್ ಪ್ಲೇಟ್ನ ಮೇಲೆ ನಾವು ಕರೆಂಟನ್ನು ಇಂಡ್ಯೂಸ್ ಮಾಡಿದ್ದೇವೆ. ದ್ಯಾಟ್ ಕರೆಂಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಎಸ್ ಅನ್ ಎಡ್ಡಿ ಕರೆಂಟ್ಸ್. ದರ್ಫೋರ್ ದ ಇಂಡ್ಯೂಸ್ಡ್ ಕರೆಂಟ್, ಎಡ್ಡಿ ಕರೆಂಟ್ಸ್ ಆರ್ ದ ಇಂಡ್ಯೂಸ್ಡ್ ಕರೆಂಟ್ ಆನ್ ದ ಬೆಲ್ ಪೀಸ್ ಆಫ್ ದ ಮೆಟೀರಿಯಲ್ ವೆನ್ ದೇ ಆರ್ ಸಬ್ಜೆಕ್ಟೆಡ್ ಟು ಸ್ಟ್ರಾಂಗ್ ವೇರಿಂಗ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ವಾಟ್ ಇಸ್ ಎಡ್ಡಿ ಕರೆಂಟ್ಸ್? ಎಡ್ಡಿ ಕರೆಂಟ್ಸ್ ಆರ್ ದ ಇಂಡ್ಯೂಸ್ ಕರೆಂಟ್. ಮಕ್ಕಳು ನೋಡಿ, ಇಲ್ಲಿ ಏನು ಕರೆಂಟ್ ಕ್ರಿಯೇಟ್ ಆಯಿತು, ಎರಡು ಮ್ಯಾಗ್ನೆಟ್ನ ನಡುವೆ ಯಾವಾಗ ನೀವು ಕಾಯಿಲನ್ನು ಇಟ್ಟು ಮ್ಯಾಗ್ನೆಟ್ ಇಂಡ್ಯೂಸ್ಡ್ EMF ಅನ್ನು ಕ್ರಿಯೇಟ್ ಮಾಡ್ತೀರಿ, ಆ ಕ್ರಿಯೇಟ್ ಆದಂಥ EMF ಏನು ಮಾಡ್ತದೆ ಕೇಳಿದರೆ, it can oppose us the further growth. Therefore, what about eddy currents? Eddy currents are the induced current on the bulk piece of the material or the metal when they are subjected to strong varying magnetic field, or that current is also called as Foucault current. For that they are given the term the induced current. See here, the induced circulating current, looping current produced in a solid metal due to change in magnetic field or the magnetic flux in the metal are called eddy currents. For that they are given the diagram. See here, they are taken by the metallic block in which the magnetic field is there. ನೋಡಿ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಚೇಂಜ್ ಆಗ್ತಾ ಇದೆ. ದಟ್ ಇಸ್ ದ ರೀಸನ್ ವೈ ದರ್ ಇಸ್ ಅನ್ ಇಂಡ್ಯೂಸ್ಡ್ ಕರೆಂಟ್. ಯಾವಾಗ ಈ ಮೆಟಾಲಿಕ್ ಬ್ಲಾಕ್ ಅನ್ನುವಂಥದ್ದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ನ ವೇರಿಯೇಷನ್ ಇಂದ ಕ್ರಿಯೇಟ್ ಆಗ್ತದೆ, ಏನಾಯ್ತು ಕೇಳಿದ್ರೆ, ದರ್ ಇಸ್ ಅನ್ ಇಂಡ್ಯೂಸ್ಡ್ ಕರೆಂಟ್. ಸಿ ದ ಪ್ರೊಸೆಸ್ ನಾವು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್, therefore the induced current, a current rotate ಆಗ್ತಿರುವಂಥದ್ದನ್ನು ಕೊಡ್ತಾ ಇದ್ದಾರೆ. therefore the applications of eddy currents, ಎಲ್ಲೆಲ್ಲ eddy currents ಅನ್ನು ಯೂಸ್ ಮಾಡ್ತಾರೆ ಅಂತ ಹೇಳಿದ್ರೆ, the first application, an induction furnace, eddy currents are used for melting iron ore etc. induction furnace ಅಲ್ಲಿ eddy currents ಅನ್ನು ಯೂಸ್ ಮಾಡ್ತಾರೆ. that is the first application. The second application, in a speedometer, eddy currents are used to measure the instantaneous speed of the vehicle. ನೋಡಿ, ಸ್ಪೀಡ್ ಆಫ್ ದ ವೆಹಿಕಲನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು ನೋಡಿರ್ಬೋದು ನೀವು. ಅನಲಾಗ್ ಮೀಟರ್ನ, ಡಿಜಿಟಲ್ ಅಲ್ಲ, ಅನಲಾಗ್ ಮೀಟರ್ನ ನೋಡಿದ್ರೆ ಒಂದು ನೀಡಲ್ ಇರ್ತದೆ ವೆಹಿಕಲಲ್ಲಿ. ನೀವು ಎಷ್ಟು ಸ್ಪೀಡಲ್ಲಿ ಹೋಗ್ತಾ ಇದ್ದೀರಿ, 60, 70, 80, 90 ಅಪ್ ಟು 100ನ ಮೇಲೆ ಹೋಗ್ತಾ ಇದ್ದರೆ ಆ ಇಂಡಿಕೇಶನ್ ಕೊಡ್ತದೆ. ಸ್ಪೀಡೋಮೀಟರ್ ಅನ್ನುವಂಥ ಒಂದು ಡಿವೈಸ್ ಇರ್ತದೆ ವೆಹಿಕಲ್ಸಲ್ಲಿ, ಎಲ್ಲ ವೆಹಿಕಲ್ಸಲ್ಲಿ ಮುಂದೆ ಇರ್ತದೆ, ಎಷ್ಟು ಸ್ಪೀಡಲ್ಲಿ ವೆಹಿಕಲ್ ಮೂವ್ ಆಗ್ತದೆ ಅನ್ನುವಂಥದ್ದು ಹೇಳುವಂಥದ್ದು. ದ ಡಿವೈಸ್ ದಟ್ ವರ್ಕ್ಸ್ ಆನ್ ದ ಪ್ರಿನ್ಸಿಪಲ್ಸ್ ಆಫ್ ಎಡ್ಡಿ ಕರೆಂಟ್ಸ್. ದರ್ಫೋರ್ ಇಟ್ ಇಸ್ ಯೂಸ್ಡ್ ಇನ್ ಇಂಡಕ್ಷನ್ ಫರ್ನೆಸ್. ಹೀಗೆ ಒಂದು ವರ್ಡಲ್ಲಿ ಬರಿಬೋದು, ಇಟ್ ಈಸ್ ಯೂಸ್ಡ್ ಇನ್ ಇಂಡಕ್ಷನ್ ಫರ್ನೆಸ್ ಆ್ಯಂಡ್ ಇಟ್ ಈಸ್ ಯೂಸ್ಡ್ ಇನ್ ಸ್ಪೀಡೋಮೀಟರ್ಸ್. ದೆನ್ ಇಟ್ ಈಸ್ ಯೂಸ್ಡ್ ಇನ್ deadbeat galvanometers. Eddy currents are used to stop the damping of the coil in a short interval of time. deadbeat galvanometers ಅಂತ ಬರ್ತದೆ, ಸರಿಯಾ, ಅದರಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ. along with that, in a electric brakes of the train, ನೋಡಿ, in electric brakes of the train, eddy currents are produced to stop the rotation of the axis of the wheel. If we consider the train, either side of the wheel they are connected, either side of the wheel, that wheel is considered as a metal drum. ಆ wheel ಹೇಗಿರ್ತದೆ ಕೇಳಿದ್ರೆ ಒಂದು ಮೆಟಲ್ ಡ್ರಮ್ನಾಗ ಇರ್ತದೆ. either side of that wheel they are connected by the electromagnets. ಯಾವಾಗ ಬ್ರೇಕ್ ಅಥವಾ ಸ್ಟಾಪ್ ಮಾಡಬೇಕಂತ ಏನಿದಿರ್ತದೆ ಅವರು ಸ್ವಿಚ್ ಆನ್ ಮಾಡ್ತಾರೆ. ಆ ಸ್ವಿಚ್ ಆನ್ ಮಾಡಿದ ನಂತರ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟ್ಸ್ ಏನು ಮಾಡ್ತದೆ ಕೇಳಿದರೆ, ಈ ಸರ್ಕ್ಯೂಟ್ನ ಮೇಲೆ ಅಥವಾ ವೀಲ್ನ ಮೇಲೆ ಇಂಡ್ಯೂಸ್ಡ್ ಕರೆಂಟನ್ನು ಡೆವಲಪ್ ಮಾಡ್ತಾ ಇರ್ತದೆ. ಒನ್ಸ್ an EMF is induced which can oppose the further movement of the wheel, that is the reason why that wheel comes to rest. ಟ್ರೈನಲ್ಲಿ ಈ ಪ್ರೊಸೆಸ್ ಯೂಸ್ ಆಗುವಂಥದ್ದು ಇಲೆಕ್ಟ್ರಿಕ್ ಬ್ರೇಕ್ಸ್ ಅಂತ ಕರಿತೇವೆ ನಾವು. ಇಲೆಕ್ಟ್ರಿಕ್ ಬ್ರೇಕ್ಸ್ ಆಫ್ ದ ಟ್ರೈನ್ ಎಡ್ಡಿ ಕರೆಂಟ್ಸ್ ಆರ್ ಪ್ರೊಡ್ಯೂಸ್ಡ್. ಜಸ್ಟ್ ನೀವು ಇಷ್ಟು ಮಾತ್ರ ಬರೆದ್ರೆ ಸಾಕು. ಇಟ್ ಇಸ್ ಯೂಸ್ಡ್ ಇನ್ ಇಲೆಕ್ಟ್ರಿಕ್ ಬ್ರೇಕ್ಸ್ ಆಫ್ ದ ಟ್ರೈನ್ಸ್. Then in energy meters, watt meter, eddy currents are used to measure the consumption of electric energy. ನೀವು ನೋಡಿರ್ಬೋದು ಮನೆ ಮೀಟರ್ ಬೋರ್ಡ್ನ ಮೇಲೆ ಒಂದು ಸರ್ಕ್ಯುಲರ್ ಟೈಪ್ನ ಡಿಸ್ಕ್ ರೊಟೇಟ್ ಆಗ್ತಾ ಇರ್ತದೆ. ದಟ್ ಮೀಟರ್ ಇಸ್ ಕಾಲ್ಡ್ ಅನ್ ಎನರ್ಜಿ ಮೀಟರ್ ಅಂತ. ನೀವು ಡೈಲಿ ಎಷ್ಟು ಯೂನಿಟ್ ಕರೆಂಟನ್ನು ಯೂಸ್ ಮಾಡ್ತೀರಾ ಅಂತ ಹೇಳುವಂಥ ಒಂದು ಮೀಟರ್ ಏನು ರೊಟೇಟ್ ಆಗ್ತದೆ, ದಟ್ ಇಸ್ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಆಫ್ ಎಡ್ಡಿ ಕರೆಂಟ್ಸ್. ಆರ್ ದ ಅಪ್ಲಿಕೇಶನ್. ಎನಿ 2 or 3 ಅಪ್ಲಿಕೇಶನ್ ಇಸ್ ಇಂಪಾರ್ಟೆಂಟ್. ಎನಿ 2 or 3 ಅಪ್ಲಿಕೇಶನ್. ಇದರಲ್ಲಿ ಯಾವುದಾದ್ರು 2 ಅಥವಾ 3 ಬರೆದ್ರೆ ಆಯ್ತು, ಸರಿಯಾ? ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಡೆಫಿನೇಷನ್ ಅಲಾಂಗ್ ವಿತ್ ದ ಅಪ್ಲಿಕೇಶನ್. ನಾನು ಪ್ರೊಸೆಸ್ ಏನು ಹೇಳಿದ್ದೇನೆ, ಜಸ್ಟ್ ಯು ಹ್ಯಾವ್ ಟು ನೋ ದ್ಯಾಟ್. ಟೆಕ್ಸ್ಟ್ ಬುಕ್ಕಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ. By this we are ended with this class. Next class we will start with the new concept or the continuation of the concept. Thank you.